Here's our objectives for scientific notation. We'll change from ordinary or decimal notation to scientific or standard notation and vice versa. And then we'll do operations with numbers that are in scientific notation. All right. So here's a few examples of why scientists like to use scientific notation. This is a pretty awkward number right here. And so instead of saying 149,400,000,000, blah, 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 we would rather just use a very simplified scientific notation of 1.494 times 10 to the whatever, right? The national debt, right? This is from 2005. It's much bigger than that right now, and so on. Very small numbers as well, if you will, like to use, especially in such numbers with this. With our conventional notations, pretty cumbersome. I like that commentary. That's why I wrote that in there. So, thus the need for scientific. So, how do you use scientific? So, here's our rule. The first p term has got to be greater than or equal to 1 and less than 10. So, that p term, it's got to be greater than or equal to 1, less than 10. And then it'll be times 10 to the whatever power, right? 10 to the positive or 10 to the negative. So here's let's look at this first one here. Distance of the Earth is 149,400,000,000. So right now, the decimal is right here. And I want it to be, remember that p term, I want it to be greater than or equal to 1, but less than 10. So I want it to be right there between the 1 and the 4. So I'm going to move it over. So I just want to count how many digits over it is. Oops. I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to write this as 1.494 times 10 to the 11th. That's our scientific notation, right? Because 10 to the 11th is 100 billion, sorry. So if you take 1.494 and you multiply it by 100 billion, guess what you get? You get that 149,400,000,000 number, right? So it's the same number. It's just written in scientific notation, right? Here's another one. In 2016, U.S. national debt was, let's count how many digits over. Right now, the decimal's right there. So what's our p term? Where's the decimal going to be, you guys? You can either microphone it or type it into the chat there. Where do you want that decimal to be? Between what two numbers? So we want to move it right between that. So 1.9442 times 10 to the, let's see how many times we move that over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So times 10 to the 13th. 1.9442 times 10 to the 13th. Okay. All right, I'm going to pause and have you guys do the first two, and then I'd like to do the last two there together. Okay. So once you guys put into the chat. Awesome, very good, you guys. Now let's do the third and the fourth one. So the third one is 0.000052. Now this time we want it right there between the 5 and the 2. So 1, 2, 3, 4, 5. So 5.2 times 10 to the negative. How many times did I move that? 5 digits. 1, 2, 3, 4, 5. Right? Because 10 to the negative 5, right? If you think about that, that's 10 to the negative 5 is 1 over 10 to the 5th. So what you're doing, 10 to the 5th is 100,000. So what you're doing is you're taking, if you multiply numerators, 5.2 divided by 100,000, that's your original 0.000052, right? So 5.2 times 10 to the negative 5 for that one. And let's do this last one, 0.0108. I want it between right there, so I'm going to move it over. 1.08 times 10 to the negative, I moved it twice, times 10 to the negative 2. Okay. And I actually think it's easier to go this way from scientific to ordinary notation. So let's go ahead and do a few of these. So 4.2 times 10 to the 5th. So that just move it right 5, right? You got 4.2. One, two, three, four, 5. So 420,000. 420,000. Because again, what it's doing is it's taking 4.2 times 10 to the 5th, which is 10,000. So 4.2 times 10,000 is, whoops, 1, 2, 3, 4, whoops, I missed one, sorry, times 100,000 is 420,000, right? That's what it's doing. So 7.12 times 10 to the negative 11. So that would move the decimal which direction, you guys? Good. Yep. Move it to the left. 11. Exactly. 7.2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 7.2 times 10 to the negative 11. Looks like there's 10 zeros and so on. All right, let's do 8.04 times 10 to the third. Again, that'll move it right. 1, 2, 3. So 8,040. Last one, 0.24 times 10 to the negative 5. All right. Adding and subtracting in scientific notation. I put a little commentary in here. I like to follow the order of operations by finding the multiplication values and then I add or subtract. In other words, I put it into ordinary for these ones here, and then I'll put it back into scientific notation if it needs it, right? So here's our first one. 2.2 times 10 to the third. Well, 2.2 times 10 to the third, I'm going to move that right. 1, 2, 3. So that's 2,200. And then it's being added to 5 times 10 to the third, which is 5,000. All right, so we end up with 7,200, right? We add the 2, but then they want that in scientific notation. So in scientific notation, that would be 7.2 times 10 to the third. Let's do that next one. 0.0056 times 10 squared, so 0.56 minus 2.8 times 10 to the negative 3 would be 0.0028. So then we take 0.56 minus 0.0028. You can just punch that in. You get 0.5572. And then we want to put that in scientific notation, right? Because they want this thing in scientific notation. So I want the decimal right there. I got to move it over. 5.572 times 10 to the negative 1. All right, and again, I would check that one in red by moving it left one to make sure you get, when you move it left one, you get 0.5572. Okay? What do you guys think? Let me give you a couple more. I'll just have you, let me have you guys try these ones here. How about, let me go 6.4 times 10 to the negative 3 plus 4.2 times 10 to the negative 1. You guys try that one right there. So go ahead and check yourself with that right there, and let's move on to multiplying numbers in scientific notation. So you can do the same approach when you're multiplying. I like to multiply the p-values and then deal with the exponents with the powers of 10. I'll show you what I made, and then we'll get into dividing with scientific notation as well. But let's go ahead and do this first one here. So I'm going to go 4.7 times 3.2. I'm going to do that. And then times, notice I have 10 to the 6th and 10 to the negative 2. So I'm going to use this rule, a to the m, a to the n is a to the m plus n. So 6 plus negative 2 is 10 to the 4th, right? And I'm going to multiply 4.7 times 3.2, and I get 15.04. Well, the only problem is 15.04 is not between greater than or equal to 1, but less than 10. So I gotta move this over 1. So I gotta write that as 1.504 times 10 to the 1, and I still have that 10 to the 4th right there. Well, 10 to the 1 times 10 to the 4th is 10 to the 5th. Okay? That's how I'm going to do that one. Now, the second one is not in scientific notation, so I'm just going to go ahead and take my calculator and punch in 0.0153 times 0.608, and I'm going to get 0.009324, and then I'm going to go ahead and put that in scientific notation. That's the easiest way to do that one. So now I'm like, well, I got to move that to there, 9.3024. So I moved it. I'm going to check it, right? if I take that 9.3024, I got to move it left to get it back to 0.009324. So it'll be 9.3024 times 10 to the negative 3. All right? And then we could do this next one, either of those approaches. Let me do it the first way. So let me put this in scientific notation. So that's 7.95 times 10 to the 4. And then and I have 8.54 times 10 to the negative 3. So I'm going to multiply 7.945. I'm going to multiply that by 8.54. So this becomes 7.95 times 8.54 times, and then I have a 10 to the 4th from here, and I have a 10 to the negative 3. Well, if I multiply 7.95 and 8.54, I get 67.893. And then 4 plus a negative 3 or 4 minus 3 is 1. But notice this is not in scientific notation. I got to move that over. So it'll be 6.7893 times 10 to the 1. And then I still have that other 10 to the 1. So it'll be 6.7893 times 10 squared. Because I got 10 to the 1 times 10 to the 1. The division. So with division, what I'm going to do here, right now I have 9.62 times 10 to the 12th. Let me just write it with parentheses here. I have 9.62, I have 10 to the 12th as my numerator. Denominator I have 3.28, and I get 10 to the negative 11. So what I'm going to do is I'm going to go ahead and divide 9.62 divided by 3.28. And then I'm going to use this rule for the tens. A to the m over a to the n is a to the m minus n. So this will be times 10 to the 12 minus negative 11, which will give us 12 plus 11, which is 23, right? But now I'm going to punch in 9.62 divided by 3.28. And I'm lucky this is in scientific notation right here. 2.93. Let's see, what 9.62 divided by 3.28. Oops. 2.9329268269. And that 2.93 number, that is less than 10 and greater than or equal to 1. So I don't need to do anything else from here. Okay. Let's do this next one now. I've got point. This one's in ordinary notation on the top. And the bottom is not. Let's go ahead and move this left 7. 9.03 times 10 to the negative 7. So let's move it left 7. And now let's go ahead and just divide these two. So I have 0.000385 divided by pull up my decimals on this. Let's see. Decimals.com, desmos.com, and I have point. Let's see, it was 0.0000385, and is divided by 0.123456903. Enter. And by the way, some calculators will give you issues with this. So we get 42.63. Let me go ahead and write that down. And then we're going to go ahead and put that in scientific notation here. So for, and it's funny, this right here, my TI-84 just said error, it couldn't handle it. So I'm kind of surprised that Desmos did it. That's pretty solid. So let's move this over one. 4.263565891 times 10 to the 1. Right? Now let's go ahead and check this and see how solid this is in our calculator. What I'm going to do is I'm going to put the first one in scientific notation. 1, 2, 3, 4, 5. So 3.85 times 10 to the negative 5. Bottom is 9.03 times 10 to the negative 7. And now what I'm going to do is I'm going to take the 3.85 and divide it by 9.03. And then I'm going to take my tens. So negative 5 minus negative 7. So negative 5 plus 7. So I'll have 10 squared right here. Now I'm going to go 3.85 divided by 9.03. And I get 0.4263565891. And of course we got to move that over. So 4.263565891 times 10 to the negative 1. I still have this 10 squared. Negative 1 plus 2 is 10 to the 1. And you notice it's the same both ways. So Desmos is pretty solid handling those very extreme value decimals, very small numbers. My TI-84 couldn't handle it. So here's an application for it. Find the power dissipated in a resistor if a current of that many amps produces a voltage drop of that many volts across the resistor using the formula P equals I times V. Here's our power dissipated. I is our current in amperes. V is our voltage. And we're going to express this in scientific notation. So you notice they give us the current, and then they give us a voltage right there. So we're just going to go ahead and multiply those. So the power would be the current, 3.75 times 10 to the negative 3 times the voltage, which they give us as 7.24 times 10 to the negative 4. And now I'm going to go ahead and multiply 3.75 times 7.24. And then I'm going to multiply 10 to the negative 3 times 10 to the negative 4. So that'd be negative 3 plus the negative 4. So negative 3 minus 4, or 10 to the negative 7. And then I'm going to punch in 3.75 times 7.24. I get 27.15. Well, 27.15 is not in scientific notation. I'm going to write that as 2.715 times 10 to the 1. And then I got to combine 1 plus negative 7 is negative 6. So I got 2.715. Oh, I'm sorry. That would be... oh, that's right. Sorry. 3.75, 7.24 is 27.15. And then 1 plus negative 7, negative 6. So I got 2.715 times 10 to the negative 6. Thanks for watching.